So let me go over the solution for assignment 3. The assignment 3 was related to confidence interval and hypothesis testing. We have two type of tumor, and we had a sample of those tumor for type 1, 20 sample, and for type 2, 12. And these were the average 3.5, 2.7, 1.8, 1.5 was the standard deviation. I ask you to calculate 95% confidence interval for type 1, 95% for type 2. Basically, 1 minus alpha, which is our confidence interval level, was 0.95. Therefore, your alpha is 0.05. 1 minus alpha over 2 is basically 1 minus 0.025, 0.975. So, and from the T table, T for the first one, 20 minus 1.975, you find 2.093. So then you're using the confidence interval formula, 3.5 plus minus 2.093 times 1.8, your standard deviation, over a square root of n, which is 20. And if you simplify that, you get 2.66 and 4.34. That's for type 1. The same way you calculating, you find your T from T table, which is TF14, and 0.975 is 2.1448. And you calculate for type 2, 1.873.53. So 1 and 4 was the correct answer for A and B part. And if this interpretation is correct, when you interpreting the confidence interval, you would say you have whatever level is asking you. Here was 95% confidence. The true mean or the population mean of tumor size for type 1 and type 2 are between those value respectively. That was true. Now, the C part, what is the 99% confidence interval with difference between those two tumor sites? So first you want to calculate the pool variance. So N1 minus 1 is 19 for sample 1, 1.8 US squared because that was your S, and 14 times 1.5 squared, you get 2.82. Now 3.5 minus 2.77 plus minus, you find the t value, which is t n1 plus n2 minus 2 and 1 minus alpha over 2. See, I said 99%, which means 0.01 is your, you divided that would be 0.005, which is 0.995. So basically, you the same way you calculate the standard error, which is the pool variance divided by sample 1, pool variance divided by sample 2, and you get that difference. So, and what it means we have 99% confidence the true difference of means of tumor size type 1 and 2 are between these two values. In question 2 was proportion. So 116 men smoke out of 430, 73 women out of 380. The proportion for men would be easily calculated as 116 divided by 430.2698, which 0.27 is correct answer, and 73 divided by 380.921, which is 0.19 rounded. That is the correct answer. Now, what is the confidence interval for both of these? Basically using the p hat. So you have your 0.2698 plus minus 0.975, and when you calculate, you get 0.226 and 0.3136 for men, and the same way you calculate for women, you get 0.153 and 0.231. And what it means if this is true, we have 95% confidence that the true proportion of the smoker for men is between 0.226 and 0.3136. Also, there is 95% confidence interval that the true proportion of smoker women is between 0.153 and 0.231. So that is true. So basically the confidence interval, the purpose is you find what is going to be in your population, the lower bound and upper bound. The F part, I ask you to find the difference between these proportion. Again, I use the larger proportion minus and then plus minus the alpha, and then we find using the formula P1 hat times 1 minus P1 hat divide 430 plus PA2 hat minus 1 minus PA2 hat, and then you can calculate 90, which is 0.03 and 0.13, the correct answer. For question 3, again, we have a sample of 49, and we know what was the population mean standard deviation, and the average was 6 for outpatient visit. So because you know your sigma, and one sample you're using one sample z-test. And what is the z statistic? Simply when you research conclude the population mean greater than 5 visit. So we want a hypothesis again 5. So the 6 minus 5 divided by 3 over square root 49 is 2.33. And can we conclude that if sort of the population is greater than 5? When you set up your hypothesis, the greater is one side z-test. So and from the z table, 0.05 would be 1.645, and here for alpha, and then here you compare 2.33 to 1.645 is greater. So we reject null and conclude alternative, which is greater. Now, let's say a research who study on daily calorie intake for certain adult population. We have sample of 36, they mean 1900 with sample standard deviation of 100. So again, here you have your sample standard deviation. You're using the you're using the T statistics for this problem, not the Z. So again, the option you have here would be to use the so you're using the for problem 4, you're using the T statistics, and because you have one sample and your variance is unknown. And here the way you set up your hypothesis here, again, can researchers conclude the population mean of calorie intake is greater than 1801? So again, it's one side because you have the keyword greater. So this is your hypothesis in the mu 1801, and alternative is greater. So Tn 1.99, our alpha was 0.01. So T 35.99 is 2.438. That is the value you're going to compare to. And the statistic is 1900 minus 1801 divided by 100 square root of 36, 5.97. This value is much greater than this value. Therefore, you reject and you would say yes, because T is that statistics greater than T value from table. You can conclude your question alternative. Question 5, we have physical activity, and this is the information we have for each of sample information. Because you have two samples and you don't have population information, you're using two sample t-test when population variance is unknown. And what is the pool variance? The pool variance, simply using the pool variance, is here the pool variance is 82. And now what is the t statistics? Basically you calculate your mean from sample 1 minus sample 2 divided by a standard error, which is pool variance divided by each sample, which is the same 100 for both samples. You get negative 7.81. And here the question was, can we conclude the mean physical activity is different? So there is no directional, so it's two-side t-test. So you find T1 minus alpha over 2 or T 0.995 because our alpha was 0.01, either greater than 2.6 or less than negative 2.6, you would reject, or the absolute value of your test statistic greater than T from table, you reject. And this value, obviously, the absolute value 7.81 is much greater than 2.6, so you reject and conclude, yes, there is different, because there is a difference between control and intervention in terms of physical activity. Question 6, it was match per t-test because you have before and after, baseline and 3 months, and dependent. So that's a statistical 1 per sample t-test. I ask you to calculate the t statistics and do a hypothesis testing if it is improved. Improve, again, is directional, is one-side t-test. So basically, I took the difference between 3 months and baseline, 100 minus 120 is negative 20. Then I square that for each observation, added up. So D bar basically is adding up all these divided by 10, which is negative 24.2. And we have using the formula to calculate the variance, and then using the t statistic. And when you look at the table, the value from table would be negative 2.821 because you have 10 observation and alpha was 0.01 is one-side test. So negative 2, and because the direction is to left, you're using the negative one here. And since the absolute value 6.65 is greater than 2.821, you reject the null and conclude the alternative. Question 7 was we have variance and we calculate. We have two proportion, and we wanted to do the hypothesis testing for those two proportion. So again, two proportion population test is correct. Always you calculate z statistic for proportion. So in the test we wanted to do at alpha 0.01 if quitting a smoker with new treatment is greater. So it's one side. Again, you have one side. So here you'd say P2 minus P1 equals 0. Alternative is P2 minus P1 is one side. And the alpha is 0.01. So 1 minus alpha is 0.9. 0.99 is 2.3. So if we are statistics greater than 2.33, you reject. If it's less, you fail. So here we calculate our proportion for sample 1, 0.8, sample 2, 0.7. There is another alternative way you can do P bar 80 plus 70 divided by adding up both samples 0.75 and then using the Z formula 0.8 minus 0.7 times 0.75, 1 minus P bar, which is 0.25, and then times 1 over 100 plus 1 over 100, you get 1.633. Obviously, this number, your statistic is less than your Z from table. You fail to reject, so you cannot conclude the question based on the quitting smoke, new treatment is greater than standard treatment. Now, the question 8, what I asked you to do, it was testing for variance. So obviously we have one sample variance, so it would be one population variance. The testing, because the question was, can we conclude this data that population variance different from 2000? There is no direction. So hypothesis testing is a two-sided test, not one-sided test. So here you have to make the decision rule in two ways. Either your chi-square is greater than chi-square 19.025. So your alpha is 0.05. So and then 1 alpha over 2 would be 0.025. So if your chi-square test is less than 8.97, you reject, or your chi-square is greater than 32.8. If it's between these two values, you fail to reject. So we calculate our chi-square easily by n-1, the variance over the hypothesis one, the population. You get 15.2. 15.2 is not greater than 32 or less than 8.9, then we fail to reject. We cannot say the population variance is different from 2000. For the question 9, now you have two sample population and two population variance is your test. And the question here was, can we conclude from this data that the variance of anxiety for female is greater? So it's one side because you have direction here. So here we set up our hypothesis. Again, is directional for our female, which is sigma 1 squared is greater than 2. So our decision rule would be F.95, 9, and 14. The degree freedom is 2.65 from F table. If our F statistic is greater than, we reject. So your test statistic, basically your sample for female divided by male, 1681 divided by 1369, you get 1.28. Again, this value is much smaller than 2.65. We fail to reject. We cannot conclude H1 that the variance for female population is greater. Question 10, the answer was, again, looking at the article, so it's the mean was 28, the confidence was 2.4 and 55.18. So for the confidence, for overall global satisfaction was 12.63 with 7.35. And from table 2, answer 3 was correct at 10.1 and 12.9 for less high school and 13.05. So by education, you have two confidence interval you were gonna report. So these are the two value correct one here. And question factor related to a smoking college. So in table 2, what kind of test? There was two sample and t-test. What is the least p-value was 0.002. So this is the least p-value. So out of these 4 p-value, if you look at that's the